Hi, good afternoon. It's an honor to talk with everyone that could join us today. As a representative of one of thousands of geoscientists who work as consultants to private industry and government agencies to help them plan, design, and build our nation's critical infrastructure. Geoscientists are specially trained to identify geologic hazards and ground conditions that impact land use. And the engineers and contractors who design and build facilities, like the one shown here, rely heavily on the expertise, the site characterization expertise that geoscientists bring. It's a relatively small role in terms of the total dollars spent on infrastructure, but it really has a huge impact in so many ways on public safety and protecting the public's investment in its infrastructure. So the photo shown here is DC Water's Blue Plains facility, and it's the largest advanced wastewater treatment plant in the world. DC Water is in the middle of a multi-billion-dollar program to install a new system of deep tunnels and sewers and diversion facilities to help clean up the Anacostia and Potomac rivers. And it's really a great example of a major infrastructure project for which geoscientists are playing a huge role in the massive subsurface investigation to determine subsurface conditions along 20 miles of new tunnels, and they're 100 feet below the ground. So it's infrastructure projects like the one for DC Water and those shown here that really help drive our nation's economy. So the U.S. spends billions of dollars on public transportation and water infrastructure each year, typically about 2.5% of GDP. And I don't have to tell anybody infrastructure is really expensive. It's getting more and more expensive all the time, in fact. Through site characterization, geoscientists provide a critical service to help ensure safe, cost-effective civil works that last for generations. And every one of these projects need a thorough site characterization to understand site conditions that impact land use. Also to evaluate the suitability of the site for the envisioned purpose and identify the site's engineering properties for the design. So ground conditions are extremely complicated and diverse. For example, in this United States Geological Survey geologic map, some may see randomness approaching chaos even, but a geologist sees order and predictability based on an understanding of the geologic processes that form and shape the ground. Within each of these units shown here on the map, there is even more complex variability in material types and properties, and that complexity extends all the way down to the microscopic scale. So with all this complexity in earth materials, you may ask, how do we get a handle on evaluating the site's suitability for infrastructure development? And the answer is site characterization. And for any given infrastructure project, geoscientists perform the site characterization to predict the distribution and engineering properties of the soil and rock materials, the groundwater conditions, and also the related changes that the site may experience over time. In a basic form, I like to think of the site characterization process as multiple cycles of gathering information, analyzing the data that's obtained, and developing a predictive model of ground conditions. So the process typically starts with reviewing the proposed development plans and the existing geologic information, such as geologic maps, hazard maps, and previous investigation data. Geoscientists analyze this early information to develop a preliminary conceptual model of the subsurface conditions that provide a basis for planning and executing a targeted and more detailed site investigation. And often the investigation on the site will be performed in steps or phases to ensure cost effectiveness in the investigation program. So with each phase of investigation comes another loop around this site characterization cycle, leading to subsequent improvements of the site characterization model. So the field study usually includes some element of site reconnaissance, whether it's detailed geologic mapping to look for red flag issues for the development, or simply a quick walkthrough to identify access for the investigation equipment. But the larger part of the investigation is the subsurface investigation. It involves drilling and probing and downhole testing. And there's many, many techniques that we use to probe and test the ground conditions during drilling. So unfortunately, we can't open up the ground unless you have a quarry, but you can't open up the ground to see it all. We can only perform limited investigations and piece together the subsurface model from widely spaced pinpricks into the ground. So a geoscientist worth half his salt in performing site characterization will have spent a lot of time behind a drill rig, many of the ones like you see here. And to a large extent, this is really how we see below ground. Geophysics and geophysical techniques offer another way to look into the ground. And the beauty of geophysics is that it provides a continuous profile of information, fills in important details between the more widely spaced borings. So this example shown here, it shows how resistivity imaging, which is a common geophysical technique, was used in combination with borings to investigate karst terrain. It was used during a siting study to locate site development away from areas that are susceptible to sinkhole formation. So at the end of the process for site characterization, all the information and analysis is stitched together to form a predictive model of subsurface conditions. And I think this cross-section shown here, it's a cross-section of the ground below a proposed dam foundation. It provides a great example of how a wide variety of subsurface investigation data comes together into a site characterization model. In this example, there were a variety of techniques: vertical borings, angle borings, soil testing, rock coring, packer testing, pressure meter testing, a variety of geophysical techniques. A lot of information comes together to form the model. And with models like this, that's how we can evaluate a site's suitability for development, predict the engineering properties for design, and identify the key risks. So many of you will probably remember what happened about 3 years ago in Kentucky at the Corvette Museum. And it's a good example of what can happen when a subsurface characterization is not performed adequately or doesn't capture the hazards associated with development. And I bet they wish they'd done a little more site characterization here to evaluate the site's suitability for the development. Thank goodness nobody got hurt, but some nice cars were damaged. Our public safety and the reliability of our infrastructure depends on a thorough and targeted site characterization. Many case histories have shown that most failures are caused by not understanding the subsurface conditions. And that means these failures could have been avoided. So landslides, sinkholes, foundation failures, tunnel and retaining wall collapses, these are the types of disasters that we really have to avoid. But also consider that most ground-related problems may not be this dramatic, but they still have a huge effect on the cost and maintenance and longevity of our civil works. And as you look at these photos, I'll leave you with a couple of parting thoughts. First, we need a national infrastructure plan that includes direct long-term funding solutions for the Highway Trust Fund, water, and other federal infrastructure programs. And they should include incentives for P3s. P3s work, public-private partnerships, P3s. P3s work in certain situations, but they're not the whole answer. So direct funding is sustained long-term funding is critical. Secondly, quality-based selection, QBS, is extremely important for engineering design, of which the geologic site characterization plays an important role, as I've talked about. It's through the QBS process where the most appropriate professional or firm is selected based on qualifications such as knowledge, skill, and experience, rather than just simply on fees or low cost. So I urge you to fight any attempt to weaken federal QBS requirements. And with that, that concludes my portion.